Welcome to The Explainer. Today we're going to jump back to 1949 to decode the story of the Manchester Mark I. Now, this was one of the world's first true computers, and it did way more than just crunch numbers. It kicked off a massive debate about intelligence itself that, believe it or not, we are still having right now.
So let's start with this challenge, thrown down over 75 years ago by a pretty prominent neurosurgeon. And look, this wasn't just some random off-the-cuff remark. It was a direct shot at this revolutionary new machine that the newspapers were sensationally calling an electronic brain.
So to really get what all the fuss was about, we're going to break this story down into 5 parts. We'll meet the machine, get our heads around its core brilliant idea, peek inside at the hardware, see what it actually did, and then we'll circle back to that very first AI debate.
All right, so let's set the scene. We're in post-war Britain at the University of Manchester. A small team there is building something the world has literally never seen before. And yeah, the press just ran with it, dubbing it the electronic brain.
Now, this thing didn't just appear out of thin air. It was really the big brother of a smaller but successful prototype from 1948 that was affectionately known as the Manchester Baby. So by April of '49, this bigger, much more powerful version was up and running, ready to show the world what it could do.
But why? Why go through all this trouble? I mean, what was the massive problem they were even trying to solve? Well, the answer is this single, absolutely brilliant idea that separates a machine like this from every calculator that ever came before it.
Okay, this brings us to the absolute heart of the matter. The idea that defines not just the Mark I, but seriously, every single digital device you own today. It's called the stored program architecture. You have to understand what a monumental leap this was. Before this, you had machines like the famous ENIAC, and if you wanted to change its program, you had to physically, I mean literally, spend days yanking out hundreds of cables and plugging them back into a different spot. It was brutal. The new solution? What if the instructions, the program itself, were just treated like any other piece of data you could load into memory?
So this big idea, pushed forward by giants like Alan Turing and John von Neumann, meant a computer could switch from, say, calculating artillery tables to running a weather forecast almost instantly. All it had to do was load a new program. That single principle, that's the bedrock of modern computing, period.
Okay, so you've got this amazing concept, but what did it actually take to build it in 1949? Well, let's just say it took a whole room full of brand new and very, very fragile technology.
This machine was an absolute monster. We're talking over 4,000 vacuum tubes for its brain power. Think of them as ancient, super fragile ancestors of today's transistors. It guzzled 25 kilowatts of power. That's enough to light up a whole street. And for its memory, it used this wild new tech called Williams tubes, which were basically hacked cathode ray TV tubes.
But here's where the team's real genius kicks in. It wasn't just about building the machine, it was about making it usable. And their biggest contribution, maybe ever, was the invention of something called index registers. This, right here, was a total game changer for writing programs.
Think about it like this. Say you needed a program to read a list of 100 numbers. The old way, you had to write 100 separate commands. Read number 1, read number 2. You get the idea. Painful, right? With index registers, you could just write one command inside a simple loop. The register was like a magic bookmark that automatically pointed to the next number in the list for you. It saved an insane amount of time and effort.
So the machine is innovative for sure, but the real test was, is it reliable? Could it actually do some serious work for a long time without conking out? The team decided there was only one way to find out.
So on this one night, June 16, 1949, they gave the Mark I a real marathon to run. They tasked it with hunting for these very specific, very large prime numbers called Mersenne primes. This wasn't a quick sum. It was a long, grueling test of the machine's endurance.
So how did it do? It ran for 9 straight hours, without a single error. This was huge. This wasn't just a, hey, it works moment. This was proof that this massive, complicated, fragile collection of tubes and wires was actually a stable, reliable computing engine.
And that 9-hour run? That's the moment everything changed. It's when computing pivots from being a cool university project to being a real business. That proof of reliability was all the industry needed. The British government immediately ordered a commercial version, the Ferranti Mark I. The team filed 34 patents, and guess who licensed them? A little company called IBM. This one machine's success didn't just help start an industry, it basically invented it. So let's bring it all the way back to where we started, because the machine's incredible success kicked off this huge philosophical brawl, one that is still defining the world of artificial intelligence to this day.
You had the scientific establishment, the old guard, who were just not buying it. Sir Jeffrey Jefferson, this top neurosurgeon, pretty much laughed at the whole electronic brain idea. He basically said, don't expect us to make room for these things at the Royal Society anytime soon.
But then you had one of the machine's own visionaries, Alan Turing, who saw things completely differently. He shot back saying, look, this is just a taste of what's coming. He argued that there was absolutely no reason a computer couldn't eventually jump into any field that the human mind could tackle.
And there you have it. The world's first true computer didn't just leave us with patents in a new industry. It left us with one of the biggest, most profound questions of our time, the exact same question we are wrestling with at the cutting edge of AI today. Can a machine truly think, feel, and create? That whole debate started right there with the Mark I back in 1949, and it is far from over.